Okay, guys, we're going to start with number one. This is about law of sines. And I want to show you the triangle first, and I'm going to give it a name, ABC. I like to put my vertices on the smallest angle. I usually like to call it A. And then the next bigger angle, I call it B. And my largest angle, I call it C. Ladies, put the phones away. You don't necessarily have to do it this way, but it for me, it makes it easier. Now, the most important part is that across from angle A is side little a. This is the length of this side. We could also call it BC, but for me, I prefer to use little a and capital A for the angle. Across from capital B is little b, which happens to be 15 meters long. It's right here. And across from angle C is little c, which happens to have the value x. Now we're going to use the law of sines today. And the two that we're interested in is this one, because we have an opposite angle and an opposite side. And this one, we have an opposite angle and the opposite side. So we're going to say little c over sine C is equal to little b over sine B. Be sure and put your name on this if you didn't. It's period 6. I think I had 3 or 4 people turn them in without names today. All right. So I'm going to write my generic formula, which says that A over sine A is equal to C over sine C. And for question number 1, the little a, B, my bad. It's B and sine B. Sorry, guys. I got to pay attention. This is B and sine B. Little b on my equation is 15. Sine B is 43 degrees. Yep. Little c on this one is, we're going to call it x. And sine C is 70 degrees, so sine of 70 degrees. I normally don't write this first. I normally just go straight to the opposite sides and angles and just write it out. So I don't normally write the generic formula for it. I just start out with this. It's pretty easy. This is the opposite side. This is the opposite angle. This is the opposite side. This is the opposite angle. These are just numbers. They're just decimals that go with these guys. And in order to solve this thing, we just cross multiply. That's all we have to do. Multiply and multiply. I've got x times the sine of 43 is equal to 15 sine 70. Again, these are just numbers. This is just a number. It's a decimal between 0 and 1. This is a number. This is a number. They're being multiplied. I want to get x by itself. That's the whole thing here. So I'm going to divide by the sine 43 on both sides. Now I could write the decimals for this and round them to the nearest hundredth, the nearest thousandth or something, but this is very accurate. If I use the calculator for this, it's gonna estimate this to the nearest like millionth. So it's gonna go out to about 6 or 7 decimal places. And we're gonna get x by itself. It's going to be 15 times sine 70 degrees divided by sine 43. Zoom out so you can see what I'm doing here. So I want to find my x, and it's going to be 15 sine 70 Now, be very careful. At this point, I had somebody make the following error. What they did is they pressed divide next. If you don't close out this parenthesis and then I put divided by sine 43, it'll put it inside the sign, which is not where you want it. So if you want to be really safe, you can close the parenthesis or just hit enter. It'll give you this decimal, but I notice that I have not divided by sine 43 yet. So if I press divided by sine 43, and again, you can close the parenthesis or not. If you just hit enter, it'll do it right. I get about 20.7 meters for this. If I round it to the nearest tenth. Now again, I could have put the whole thing in, but you just have to be careful. 15 sine 70, oops, 70. Now, if I do this, it won't work. I'm going to put this in the middle so you can see it really well. If I write divided by, and then somebody did this earlier, sine 43, it won't work because what it's going to do is it's going to divide the 70 by sine 43 and then take the sine of that. So you don't want it to do that. Let's see if it'll let me do this. I want to put the parenthesis and then I can push divide sine 47 or 43. I think it's 43. And it'll still give me the same answer. 20.7 meters. This is right here, which is M on your puzzle, and this is number 1. Now, number 2 is a different type of problem. I've still got an angle and an opposite side. I've got an angle and an opposite side, but this time they don't want me to find the side, they want to find the angle. I can still set it up in a lot the same way, though. I've got, for number 2, do you guys know what those little 2 marks mean that look like quotation marks? Yeah, that's the marks for inches. So this says 28 inches. You can put the marks or you can just write inches. I think it's safer to put 42 inches for this because sometimes they use them for different things. They sometimes mean seconds instead of minutes. So it's probably better to just use the actual units. So I've got 42 over sine x equals 28 over sine 27, or vice versa. It doesn't matter what order you write it in. So I'm going to do 28 over the sine of its opposite angle, sine 27, is equal to 42 over the sine of x. Again, I'm going to cross multiply. I have 28 times sine of x and all I want to do is get x by itself. So I'm going to follow the steps for that. I have a sine x, and I'm going to go ahead and divide by 28 on both sides so I get it by itself. So I've got all this stuff. This is just a number times a decimal divided by a number. And what I'm going to get is a decimal for this, 42 sine 27 divided by 28. Let's do that real quick. I have 42 times sine 27. Notice I closed the parenthesis, divided by 28. I'm putting the whole thing in there. You don't have to put the whole thing in at once. You could do it in pieces. But there's my decimal. Mess up. No, it's fine. So I get, notice that this 9 rounds up, so it's going to be 0.6810 if I round it. Now here's the problem. The sine of x is equal to 0.681 or thereabouts. I want to find the angle that has that sine. So one way to do that is to look it up on a really bad table. Let me show you a real bad table here. The problem with this table is that it's not very big. It's going by 5-degree intervals. And I want to find the closest thing to the sine of 0.6810. So I want to look up sine of 0.68. Looks like it's in between these two. See it? So it's somewhere between 40 and 45 degrees. Somewhere around the middle of there, 42, 43 degrees, something like that. Not very specific. I could use a better table. And I could look it up this time. This one, I'll fold it over so you can see it. I want the sine, which is in this column right here. It's this second column right there. And I want 0.681 in this column. Looks like it's almost exactly 0.682. I don't know if you can see it very well, but I'm looking for this, and what I got was 0.682, which is 43 degrees. Really close to 43 degrees. I don't recommend doing it that way. If you have a calculator, you definitely want to do it this way. We call this the arc sine. It takes away the sine and it asks for the angle that has this decimal. So we call it inverse sine or arc sine, and we just put it in the calculator and it'll find it for us. But you got to know what you're looking for. I want inverse sine. I don't know if you can see it, but the sine has an inverse in blue up here. So I press second, inverse sine, and I put in the decimal. Notice I rounded it. And I hit enter, and I get about 42.9 degrees, which is really close. In a bit, not right this second. You can hold it for another 5 or 6 seconds while I finish one more example. Equals. There we go. All right. Notice that you've got a 42.8, but you also have a 42.9 at S right here. And we want that one. And number 2 is S. Now there's an issue with number 3, and it's a big problem. This is one of the only issues that you ever run across trying to use the law of sines. I have an angle and I have an opposite side, but I don't have an angle that matches with this opposite side, and I don't have an opposite side that matches with this angle. Your only option is to find the missing angle that's right here. You need to find that angle. In order to find the angle, BB, put the phone away, please. Plus 24. Is that angle 117? Is this angle the sum of these two? No, that's not going to work. What do you have to do with it? I added these two angles together, but I want to find this one. Subtract it from 180 minus 117, and you can get your angle. What is it? Yeah, this is 63 degrees. And now you can set it up because now I have the X and I have its opposite angle. I have the number and its opposite angle, and you can set it up now. Try setting up your proportion and then solving it. I'm going to write my proportion down here. You try to write yours. I'm going to start with the x over sine 63. And that's going to go with the number, which is 48 centimeters, I think, over sine 93. And once you set it up, I know, hopefully you'd set it up correctly. I like to put my units in there if I can. If they give me units, I always put them in. You just cross multiply and solve. For number 4, 5, 6, 7, and 8, they all work out really easily. They're almost all like these. 9 requires that you find the angle A and then use it to find angle C. And then number 10 is like number 3. It's a lot like this problem. So I'm just going to put a little number 10 right there. It's kind of like that. You guys should be working on these together, help each other a little bit. I'll put some more hints up in a while. Okay.